Hi friends, today we are discussing Structural Analysis 3 Analysis of Continuous Beam by Stiffness Method Physical Approach Problem number 4. And the question is Analyze a continuous beam shown in the figure by Stiffness Method. Here we have an overhanging beam. So we have to convert the overhanging portion into a moment. Thus, MPa will be minus 100 into 3. That is 100 into 3. It is in the anti-clockwise direction, therefore have a negative sign. In case of MDE, it is 100 into 2, that is 200 kilonewton meter. It is in the clockwise direction, so we'll have the value as positive. We have to draw the equivalent structure. Now we have to find the degree of kinematic indeterminacy using the equation 3j minus r plus m. J the number of joints, r the number of reactions, and m the number of members. Thus we get a value of 3 for the degree of kinematic indeterminacy. The rotations at B, C, D, theta B, theta C, and theta D are the three independent displacement components taken. Then we have to draw the coordinates. The next step is to develop the stiffness matrix. To get the first column of the stiffness matrix, we have to give a unit displacement at coordinate 1. K11, that is the effect of coordinate 1 due to the unit displacement at coordinate 1. Since it is a near end, we use the equation 4EI by L, thus we get a value 0.8 EI. In case of K21, that is the effect on coordinate 2 due to the unit displacement at coordinate 1, we'll get a value of 0.4 EI since it is far end. K31 is equal to 0 because they are restrained in position. Similarly, we get values when we apply a unit displacement at 2 and at coordinate 3. Develop the matrix. We get the matrix as 0.8 EI, 0.4 EI, 0, 0.4 EI, 1.6 EI, 0.4 EI, 0, 0.4 EI, 0.8 EI. In the previous questions, we doesn't had any external loads, but here we have the joint loads. So P1 will be equal to minus 300 kilonewton meter, P2 will be 0 and P3 equal to 200 kilonewton meter. The next step is to find the fixed end moments. The load or the point load is not properly applied at the center. So here we have to consider the equation for finding the moment as PAB square by L square and MB equal to PBA square by L square. Consider the value as negative in the anti-clockwise direction, and for clockwise direction consider it as positive. Thus we get the fixed end moments for each members. P1 dash, P2 dash and P3 dash, the restoring forces at coordinate 1, 2 and 3 for fixed end conditions are, for P1 dash it will have the effect of BC only. So the value of BC will be minus 250 kilonewton meter. For P2 dash it will have the effect of CB and CD. CB will be 250 minus CD will be minus 180, that is 250 minus 180 will give a value of 70 kilonewton meter. For P3 dash it have the effect of only DC. The value of DC is 120 kilonewton meter. Thus form the matrix. Next, consider the equation delta, matrix delta equal to matrix K inverse into P matrix minus P dash matrix. Substitute the values. Thus, we'll get the values of theta B, theta C and theta D. N moments can be found out by substituting the values and considering the slope deflection equation. Find the moments due to the point loads and draw the bending moment diagram. If you like this video, like, share, subscribe and recommend Solve Civil. Hope you understood. Thank you.